Okay, we're going to start off by using Python as a calculator. So let's get started. We're going to start Anaconda Navigator. This is how it works on the Mac. If you're on a PC, you might need to look for a desktop shortcut or go into the programs to find it. Now what we have here are a number of development environments, IDEs. We're going to use a JuPyter notebook. Spider is another good one, but let's use this one over here. These are basically just like editors for Python programs. You can have a different editor but still edit the same thing, just like you can have different photo editors, still edit the same photos with them. So we're going to launch this one. JuPyter has become extremely popular recently as a word for data analysis in both science and in economics and artificial intelligence, so it's a good one to learn. Now what this does is it actually comes up in your web browser, in my case in Chrome. This is our navigation window. So the first thing we need to do is go to whichever directory we want to store our programs in. Let's say we wanted to store them in desktop. We click on this. Now we need to set up a new notebook. So we go up here to New, a Python 3 notebook. And here we have it. You can still go back to this to navigate between different files. You can now see a file called Untitled.ipnb exists, which is this one we're looking at in this window over here. Now the way this works is there are a number of cells. Here's one cell, and you can type command in each cell and then execute that bit of command and then go and fill up another cell. Now what we're going to do is we're going to write a Python program which is acting as a calculator to calculate if you throw something vertically up, where will it be at different heights. Now the equation for that is s equals ut plus a half at squared. So the first thing we're going to do is set up our variables. So we need the starting speed, which is normally called u. So that equal to, let's say we throw something up at 20 meters per second. And we need the acceleration, which is equal to minus 9.8 meters per second squared, because that's g downwards. And we need the time, so let's calculate where the ball is, say 1.3 seconds after we threw it up. Now what we're doing here is we are defining Python variables. When I run this, it will set aside a place in the computer memory which has the label u and contains the number 20. It will set aside another place in the computer memory with the label a and a value of minus 9.8, and a third with the value t and 1.3 in it. Now to run the cell, we need to click in the cell so it's selected, which means it's got a green bar around the outside. And then we can either go cell, run cells, or more easily, we just go in here and press down the shift and return keys at once, and it runs it. Now there isn't much to show for it having run, but now it has set aside 3 parts of the computer memory and given them the names UAT and the values 20, minus 9.8 and 1.3. We can check that because now we can print. So we can print, say, U, and if we do run that cell, so shift and enter in this shell, it tells us it's 20. So what happened is, this is a function in Python. Function is always a name, and then it's got round brackets at the end, and inside that you put what its function is of. In this case it's u, so we're printing u. So when I ran this command, it said, "Oh, u, I remember that. That's a label for a variable in our memory." And it went and dug it up and found the number 20 in it, so it printed 20. Okay, so we've got that. Now we need to put our equation down for the distance. We'll do it in the third cell, so we'll click in that. Now, a few rules for doing Python equations. We'll have s equals ut. Now that's u multiplied by t, and the way you show multiplication in Python, and in fact in almost all programming languages, the star sign. So ut is u, that's u star t means u times t, plus half. Now you do division by the 1 over something else, half times the acceleration times t squared. Now the way you do squared is 2 stars, 2. So that means t to the power of 2. Okay, is that all making sense? So we've got the distance s equals u times t, that being the star, plus 1/2, 1 divided by 2 times a times t star star 2, which means t squared. And what we're also going to do is we're going to print s. Okay, now we can run that cell. So we're in that cell, shift return, and it tells us it's at the height of 17.719 meters at the time we set up here, which is 1.3 seconds. Now we can change the time, so let's say we make that 1.6 seconds. We've changed that, so we need to shift enter on that cell. So now these spaces in the memory have a new value for t. We could print t down here, and we can see that t is changed to 1.6. And now if we run this, it's got a bit higher. So every time you change something, shift enter for that cell and then all the cells that depend on it. Now right now this is looking a bit cryptic. You know what this does, I know what this does, but if I came back to this file tomorrow, I'd probably have completely forgotten. So let's make it a bit more clear to humans what's going on. One thing we can do is we can, instead of printing just s, we can actually print some explanation. Now if you want to print lots of things at once, you could just have a lot of print commands, but you can, for example, print lots of things by having the first thing you want to print, then a comma, then the second thing you want to print, then another comma. So now when I run this, it should print u and then a and then t. Let's see if that works. It does. So we could here try and put some text in. So we could say the height is comma s. So let's see if that works. So shift enter. Oh, it didn't work. We're getting a syntax error. What's gone wrong here? Well, the trouble is that when Python sees the word the, or the word height, or the word is, it doesn't know we want just to print them out as words. It thinks they're variables like s. So it's looking at its memory to see, is there a variable called the, and there isn't. If we want Python to realize that we just want those as words, we don't want them as variables, the way you do that is you put quote marks around it, the beginning and the end. And you see that the notebook we're using here, JuPyter, has automatically had it come out in red. This is what's called a string, and it basically means just treat it as a bunch of letters, don't treat it as a variable or anything else like that. So now if we run this, that's looking a bit better. We still don't really know what the program is doing though, so what we're going to do is put some explanation in the front. That's a good thing about these JuPyter notebooks. You can actually mix text and calculation. This is how people normally analyze complicated data. They might say, we're going to do this in some text, and then we're going to do a bit of calculation, and maybe a plot, and then they'll have some more text. So it's like a lab notebook or something. Now let's put this on a cell up the top. We're going to need a new cell up here to put some text in. So what we're going to do, we click on the top cell, and then we go Insert Cell Above. Then we've got another cell up here. And what we're going to do is we're going to change the format of that cell from code to Markdown. Markdown is basically a word processing language used often by blog writers. So I have a title, let's say program to calculate height of ball thrown up. I've got to underline that. In Markdown, underlining something means it'll come out as a header. Given an upward speed u and a time t, calculates the height reached at that moment. Okay, now select that cell, Shift Enter, and it comes out like that. So this is all looking quite pretty. This is a reusable calculation, so you could use this calculation as many times as you like. You could save it. You can see it's automatically saving what we did. It last saved 8 minutes ago. If you want to save again, just press this button here, or go to File, Save and Checkpoint. At the moment it's called Untitled, which isn't very meaningful. So what we can do is we can click here and we'll call it something more meaningful, like ball height calculation. Rename. Okay, and now if we go back here, we'll see there's a file called ball height calculation.ipynb. That's interactive Python notebook. See it's green because it's currently running, last modified seconds ago. And now we can use this if we wanted to have some other time, like 2.6 seconds, or some different upward speed, let's say 23. So we'd Shift Enter on this. Check over here that it's changed correctly. It has. This line doesn't really do anything, it's just checking for our own benefit. And then we can run it like this. And this is actually a good way to do that last step of most calculations, where you substitute numbers into the equation you've worked out. Because it's easy to check, you can actually see the equation laid out here. And you can see the numbers laid out here, so it's very easy to spot if you made a mistake, if you typed a number wrong. Whereas if the whole thing is plugged into a calculator, first of all it's not normally reusable, and secondly it's much harder to see where you make mistakes.